Okay, students, so next is question number E. Okay, 6E. Now you might have seen in the answer, if you see in the back side, the answer is little different. The reason is, in the question they have asked you strictly increasing or decreasing, and answer they are giving in terms of increasing and decreasing only. I have already explained the difference between strictly increasing and only increasing. Okay, in strictly increasing, what happened? You will find no point where the graph becomes neutral. Okay, it will be increasing in every point. You won't find anywhere where the graph will be neutral. Okay, when I say increasing only, when I say increasing, the graph might be increase. Okay, the graph might increase, but at some point it might be neutral again, and again it might increase. So it might happen like that. Okay, when it is only increasing. So I have shown you graphically also. When I say increasing, it might be like this also. It become neutral for a time being, 0. Okay, here the slope of tangent will be 0, then again increasing. So this, in this cases, we used to say the graph is increasing. Okay, but if you have strictly increasing, then you cannot say from here to here it is strictly increasing, because at a point it becomes neutral also, right? When I say strictly increasing, it means there should not be any point where the where you will have slope of tangent 0, that is derivative will be neutral there, 0 there. Okay, so when I say strictly increase, only till here it is strictly increase. After that it become neutral here, then again from here to here it is strictly increasing. Okay, so when I say strictly increasing, I have to mention it separately. Under this interval, the x function will be strictly increasing, and from this interval function will be strictly increasing. But as a whole, if I say, it will be simply increasing. Okay, so when I say simply increasing, there might be a neutral point again. Okay, there might be a point where the derivative becomes 0. Okay, but when I say strictly increasing, there should not be any point. No point should be there where the graph is neutral. Okay, so in this case they have asked you strictly increasing, but answer they have given in terms of increasing. That you will understand here in this question number E. Okay, properly. So listen carefully why I'm telling you that increasing and strictly increasing, there is a difference. So see carefully. So first thing, the question, if function is this one, I have already done so that it won't take much time. Okay, so x plus 1 cube, x minus 3 cube, right? So differentiating with respect to, so with the help of derivative only I can say, right, under which interval it is strictly increasing and decreasing, I can say for this graph. Okay, so when I derive, this will be uv form, right? So u I have kept as it is, then derive v, plus v I have kept as it, derive this. Okay, so this derivation, what form it is? X cube form, right? So 3x square. Now if you derive this one again, you will get only dx by dx, which will be 1. So no use of writing, so I have left it here. Okay, plus this as it is. Then if you derive this one again, x cube form, right? So 3x square. So again, if you derive this one, x plus 1, if you derive, you will get only 1 here. Okay, so no use of writing that also. So if you solve this one, you can see here something is common. X plus 1, x minus 3, x minus 3, x plus 1. So x plus 1 square you can take common from here, and x minus 3 square you can take common from here, right? So I have taken to 3 also you can take common. 3x plus 1 square, x minus 3 square. This is simply solving. Okay, so from here what will be left out? X plus 1 power 1 will be left out, right? 1 power will be left out because square I have taken common, right? So everything is outside, so only x plus 1 will be there. From this, what will be left out? X minus 3 will be left out, right? So solve this one, you will get 2x minus 2 here, right? So after that 2 again you can take outside, so 2 into 3 it will be 6, this one. Okay, now see here, whenever you have to find out the graph is where the graph is strictly increasing, strictly when you have to find out, your basic point is for you have to find out where the critical point is. Okay, where the graph will become neutral, you have to find out that point. So for critical point we have find out, see, f dash x will be 0, right? Derivative will be 0 there. So if you solve this one, you can see either this will be 0, this will, now this will be 0 only if x plus 1 with 0, right? So that's why I've written x plus 1 equal to 0. Okay, or obviously 6 cannot be 0, so no use of writing this equal to 0, or this equal to 0, or this equal to 0. If you want, you can write here 6 not equal to 0 if you want. Okay, so x plus 1 whole square will be 0 if and only if this and this will be 0. Okay, so x plus 1 equal to 0, this 0 and this 0. So from there x equal to minus 1, 3 and 1. So 3 critical point we got. So in the graph, if I have to show it, then it will be something like this. So you got 3 critical point, 1, 3 and -1, right? So you will see the graph will become neutral somewhere here. So on your left of -1, it might be increasing or decreasing for sure, okay? And then it will become neutral here somewhere, and then again from here the graph will start. It might be increasing like this, it might go, or it might go like this. Then again what will happen, when it reach 1, x equal to 1, it will become neutral again here. Then again the graph will change. So it might be increasing or decreasing till 3. Again at 3 it will change, okay? So at 3 again it will change, the graph will change. So I will show you that one in the graph also, okay? First let's try to find out on your left of -1 whether the graph will increase, on your -1 to 1 whether the graph will increase or decrease, whether it will go like this or like this, okay? From 1 to 3 again we will find out whether the graph is increasing, because in between 1 and 3, or if it is increasing it will be increasing, if it is decreasing it will be decreasing. There will be no neutral point because we already got 3 neutral point only will be there, okay? Other than this there will be no neutral point. On your left of this, either it will be increasing only or it will be decreasing only, okay? Strictly clear. So here it will become neutral, then again till here it will be increasing or decreasing only, then again at 1 it will become neutral, then again increasing or decreasing till 3, and 3 it will become again neutral, and then again increase or decrease, okay? So that we will find out. So till infinity, from here to here infinity, what it will be, minus infinity to this, whether it will be increasing or decreasing I want to find. So what I will do, I will take one point between -1 and infinity. So let's take from here. So if I take -2 suppose, okay, where you will take, in f dash x you have to take, okay, in place of x you take, and see whether f dash x is negative or positive. If it is negative, then we know it will be decreasing here, graph will be like this, downward. And if it is increasing, positive if you get, then it will go upward, okay? So let's take one point, any point you take from here. So let's take -2. So if I take -2 here and put it, what you will get, 6 into -2 plus 1, this will be positive only, right? Whatever you take here, -2 plus 1, so square, then -2 minus 3 whole square again, then -2 minus 1. So you can see this will become positive because whole square, this will become positive. I am concerned with the sign only, I don't need values, okay? I just need to know sign, what positive it is or negative it is, okay? So this will be positive, this will be positive, this is positive, this only will be negative, right? So if this is negative as a whole, you can see this is positive, this whatever you put here, negative value, whatever, -2 or any negative value, this will become positive. Whatever negative value you put it here, here you will get negative, square will make it positive, okay? Here also square will. So this term, this term, this term will be positive here. Now it depends only on this. So if I put -2 here, what I will get, -3, so it will become negative. So negative into any positive number here, it will be negative, as a whole it will be negative, okay? So you know that the graph will be decreasing, it will be downward like this, okay? From left it will come downward, okay? So that idea I made it here. Now let's see from -1 to 3, and here it will be downward like this, and then it will change little bit. For the time being it will be neutral, and then again it might be decreasing or it might be increasing. Let's find out. -1 to 3, so take any point. Let's take 0, better, right? So if I take 0, positive, positive, 0 if I take here, this will be negative, right? -1 you will get, so minus into anything it will be negative only, minus into any positive number, okay? Any positive number it will be negative only. So you can see the graph will be decreasing here, then it will become neutral, and then again it will be decreasing. I will show you the graph also, okay? So here till here it will be decreasing. Now again at 3 it will be neutral, and then again the graph will change. It might be increasing or decreasing. So let's find out 3 to 1 what it will be. So take any point between 3, sorry, I have made mistake. Here it will be 1, sorry, what I have written. So -1 to 1 it will be negative, okay? So 1 to 3 you take any point. Let's take 2. So if I take 2 here, positive, 2 here, positive, 2 if I take here, it will be positive. 2 minus 1 it will be positive. So all will be positive, right? Any value you take here, so it will be positive here, okay? So 3 to infinity you take any point. So you take 4. If I take 4 here, positive, 4 positive, 4 if I take, this also will be positive. So here also positive, okay? So from this I can make an idea. Minus infinity to minus 1, it will be decreasing. Minus 1 to 1, again it will be decreasing. At minus 1 it will be neutral, okay, for a time being. Then from 1 to 3, again positive, means increasing. It will go from left to right, upward. Then 3 to infinity, again it will go upward, okay. So I will show you the graph also. Let me write down first, okay. So f dash x, you can see it is, okay, they have asked you in the question on which interval it is strictly increasing or decreasing. Strictly they are asking, so very important here. So see here, when I take minus infinity to minus 1, okay, and if I don't include, then I know that it will be strictly decreasing. But if I include minus 1, it will be simply increasing, remember that, okay. So this minus 1 I cannot include. F dash x is greater or less than 0 for all x belongs to minus infinity to minus 1, and for all, I'm writing separately. Can you see? I'm not writing minus 1 to, I will show you. Let me first write down this one, then in the graph I will show you, otherwise you will not understand. Then minus 1 to 1, again it is decreasing, right? So what I have written, f dash x will be less than 0. When? Less than 0 means negative value, right? When it is minus 1 to minus 1. I'm not including minus 1, because in minus 1 it will be equal to 0. It won't be less than 0. Okay, so that's why open interval. And for all x belongs to, here also x belongs to minus 1 to 3. So you can see I have written separately this one. Some of you might be thinking that I could have taken f dash x less than 0 from minus infinity to 1, because everywhere it is negative, right? Decreasing only. Yes, minus infinity to 1 it is decreasing, but not strictly decreasing, because I told you, right, when you draw the graph from minus infinity, if you come like this, what will happen? At minus 1 it will be neutral for some time like this, and then again decreasing. So from minus infinity to 1 it will be decreasing. I can say decreasing it is, but not strictly decreasing, okay. But if I have to mention strictly decreasing, I have to mention separately this interval, separately this interval, okay. So minus infinity to minus 1 it is strictly decreasing. Minus 1 to again 1 it will be strictly decreasing, okay. As a whole, if I say, it will be simply decreasing, okay. Next, for x dash greater than 0 for all, here I didn't written, therefore the function f is strictly decreasing on, you write down interval minus infinity to minus 1 and minus 1 to 1, okay. I know some of you are still not understanding what I'm saying right now. I will show you in the graph, okay, then you will understand why I'm saying all this, why I'm putting more stress on explaining this, okay. So for all x belongs to x positive, when it is positive, from 1 to 3, open interval, again I'm not including 1 and 3, okay, open interval, I didn't do close interval. Then, and for all x belongs to 3 to infinity, again here also I have to pick open interval. Therefore function f is strictly increasing on 1, 3 and 3, infinity. So see, I will draw the graph and will explain what exactly it means. So here the answer is over, okay. So you might be thinking it was same like the previous question. Yes, it is same, but there are a lot to understand again, okay. So let me show you in the graph. Okay, so first thing, according to us, the graph will be something like this. Minus infinity to minus 1, the graph will be decreasing. So minus infinity to minus 1 is here, right? So it will be like this, minus infinity to minus 1. So suppose here the minus 1 is, okay. So at minus 1 it will be neutral, right, because critical point. Then minus 1 to 1, this is your 1, again it will be decreasing like this, minus 1 to 1, okay. This is critical point, okay? Decreasing, neutral, and then again decreasing, right? Then when it reach -1, it will become 1, it will become neutral, and then again positive. Positive means it will increase now, okay? 2, 3. So till 3 it will increase like this. So this is 3, suppose, okay? So after reaching 3 it will become again neutral, little bit like this, okay? Then again positive, right? From 3 to infinity, again positive means again increase, so it will go up. So can you see, here it become neutral, here it become neutral, here it become neutral. -1, 1, and then 3, 1, and then 3. At 3 point it become neutral, so I have drawn in that way only. And then on your left of -1 we got negative, means it will be decreasing like this. From -1 to 1 again negative, means again decreasing. Then 1 to 3 it will be positive, means increasing. The graph will go up like this, right, till 3a. Can you see? 3. Then again it will become neutral at 3, because critical point, right? Then again it will be positive from 3 to infinity, so it will go up continuously. And after that you will never see that critical point here, because only 3 we got. Here it will be strictly increasing, it will never become neutral there, okay? So if I draw the graph, you can see here. So here is the function x plus 1 cube, x minus 3 cube. This was the function, right? So if I draw the graph, see carefully. If I zoom out this one, okay, can you see? If I zoom this one, this is -1. Can you see? Here it become, obviously I have drawn here neutral. Anyway, it reach here, -1 will be here. You can see on your left of -1 it is decreasing totally. You will never see here any neutral point, right? So neutral point was -1. So on your left I got decreasing, negative, right? So you can see it is decreasing here, okay? And then it become neutral, and then again decreasing. Can you see? It is decreasing till 1 it will decrease. Let me zoom out this. You can see this is 1 point. Can you see? 1, x-axis 1. So here it become neutral, again positive we got, right? So it is increasing, the graph is increasing again. And you see, till 3 it will increase, and then at 3 it will become little neutral. You can see at 3 it become neutral for a time being, and then again increase, okay? So in general, if I say in this graph, you can see, if I say from -infinity to 1, the graph is decreasing, it is going downward, right? From -infinity to 1, exactly 1, it will be decreasing. But when I talk about strictly decreasing, when I say strictly, means there should not be any neutral point. So when I say strictly, I cannot say all. -1 to 1 I cannot say strictly decreasing. Then I have to separate this interval. I have to write -1 to -infinity to -1. -1 I cannot include, so open interval. It is strictly decreasing. Can you see? There is no neutral point. Everywhere it is decreasing, strictly decreasing till here. So I have written that interval separately, and then again -1 to 1, again strictly decreasing. So separately I have written the interval here, okay? The function f is strictly decreasing on this, I am not including -1. Can you see? And then again on -1 to 1, from -1 to 1 again strictly decreasing, okay? So they have asked in the question to find out the interval on which the function is strictly decreasing or increasing. So strictly decreasing on this interval, and similarly strictly increasing on this interval. 1 to 3, I am not including 3, strictly increasing. Then again 3, I am not including, 3 to infinity it is strictly increasing, okay? But if they ask the graph to find out whether it is increasing or decreasing, then simply we would have written -infinity to 1 it is decreasing, and then 1 to infinity it is increasing. Directly interval would have been like this. Function f is increasing on interval, directly we would have written 1 to infinity, okay? F is decreasing, directly we would have written on interval -infinity to 1, okay? And when you don't have to find out strictly decreasing all these things, you don't have to find critical point like this. Directly also you can do it like this. See here, if you don't have to find whether the graph is strictly increasing or decreasing, means directly simply if you have to find out increasing decreasing, no need to do this, no need to find critical point, directly we can do from here, because I just have to find, right, where the graph is increasing or decreasing. So what you can do is, you can see here, this whatever value you put here x, it will be positive, right? Whatever you will put here also, it will be positive. So your graph does not depend on this, because here it will be always positive. Whatever value you will take, negative or positive, it will be positive only. So your graph only depends on this one. Okay, why? Because if you take here x, you can see here x, if I take 2, then it will be positive, right? But if I take -3, -4, you can see it will be negative. So your graph totally, whatever value you take here, whatever value you take here, whatever value, this will always be positive, this 3 term. Okay, always be positive. So your graph only depends on this one, whether it will be positive, means f dash x will be positive or negative, it will depend only on this. So it will be f dash x will be, this is next part. Okay, your answer was over, that which I have written previously, that you have to write down. This is just for explanation, for whether you have, if you want to find out whether the graph is simply increasing or decreasing, you don't want to find out strictly increasing or decreasing, then directly you can do like this. F dash will be greater than 0 when, if this is greater than 0, if this is positive, everything will be positive, right? If f minus 1 greater than 0, which implies x greater than 1. Means if I show you in the graph, you can see here, what does this mean is, here everything positive, right? Now this f dash x will be positive when, if this is greater than 0, right? If this is greater than 0, means x greater than 1. Means if you take x greater than 1, anything you take, your f dash x will be greater than 0. We have seen that one, right? Means I can write f dash x greater than 0 if x greater than 1, I have seen, right? Which means function increasing if x greater than 1, means on interval, what I will write, 1 to infinity. Greater than 1 means what? 1 to infinity, right? So f is in function is increasing if not if, on interval, this one, function increasing on this. So you can see simply when I have to find out increasing 1 to infinity, it will increase. Directly you can find out like that. Okay, for decreasing means what? This must become negative, that's it, right? I don't care about neutral point here. Okay, where it will become neutral, no need. I just want to know when it will be negative. Only if this is negative, right? So this, when it will be negative, when x minus 1 less than 0, right? X minus 1 less than 0 means x less than 1. Means x, if it is less than 1, then f dash x will be less than 0, means this will be negative when, if x is less than 1. This is negative means what? Your function is decreasing. So when your function will be decreasing if x is less than 1, means what? I can take interval -1 to -infinity to 1. So can you see, function is decreasing. I'm not saying strictly decreasing. Okay, function is decreasing when, in an interval -infinity to 1. So two things you have studied here. When you have to find out simply increasing and decreasing, no need of critical point, directly you see where the derivative will become positive or negative, simply find out. Okay, if you have to find out from where to where it will be strictly decreasing or increasing, then you have to find out critical point, and then you have to find out separately the interval, because I told you critical point you cannot include in strictly decreasing or increasing, because in strictly increasing and decreasing there should not be any point where the function, where the derivative will become 0. Okay, so that's why in case of strictly increasing decreasing, critical point is very important to find out. Okay, otherwise you don't need. But again, in some cases simply you cannot find out in this way. Okay, expression won't be that simple, so in that case you might have to find out critical point anyway. Okay, I hope this one is clear. Since they have asked you to find out strictly increasing decreasing, that's why we have find out critical point first, then -infinity to -1 strictly decreasing -1 to 1. I have not included -1 because this is a neutral point. Okay, so separately you have to mention function is strictly decreasing on this and this separately. But if it is only decreasing, they would have said, then the interval would have been directly minus infinity to 1. Okay, so your best example is question number 7. In 7 also they didn't ask you to find out whether it is strictly decreasing or increasing. They are simply saying find out, show that log 1 plus x 2x by 2 plus x greater than minus 1 is increasing function of x towards its domain. Towards its domain means what? X value. Okay, whatever x value you will take, for that you have to show that it is increasing function. Okay, so here what you will do, simply find out derivative. This will be increasing on which interval basically they are asking you to find, right? Increasing function they are asking. So you just derive this one, and then f dash x greater than 0 for what interval, you find out. That's it. Okay.